Hello, everyone, and welcome to today's SANS webcast, ICS Proactive Defense, Leveraging Operational Threat Hunting for Resilience, Part 2. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Dean Parsons, SANS Certified Instructor. If during the webcast you have any questions for our presenter, please enter them into the Q&A window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Dean.
Awesome. Thanks so much, Carol. Glad that everybody could join again today for part 2 of this Threat Hunting in ICS series that we have here. So we're going to dive right in there. Don't worry if you missed part 1. It is already recorded and available, but we'll touch on a couple different things here today just to recap the first section of this series as well. So again, my name is Dean Parsons, Certified SANS Instructor for ICS 515 and the new ICS 418 class as well, and 418 being the ICS Security Essentials for Managers. My background is there, nearly 20 years experience in IT and OT and ICS converged environments and non-converged environments, from telecommunications to oil and gas refineries to electric generation, transmission, distribution, and many different types of assessments in ICS across multiple sectors. So with this series that we are doing, it's all about being proactive, preparing for, looking for threats or signs of threats before impact. So it's all about proactivity. And this is really the second part, which we're going to talk about the data sources. When you're doing threat hunting, of course, data is critical. So we'll talk about building out a hunt package, preparing for the actual execution of a hunt. And with that, we will discover some very important assets inside control systems and kind of go from there. So number 3 is, of course, the next session, but just a recap of the last section, which is part 1 of this series. We talked about the aspect of safety in ICS. We've also talked about several different freely available threat intelligence sources for the ICS area as well. Of course, sector specific is kind of the ideal state we want with threat intelligence. We also ran over the people, process, and technology aspects as well, and when specifically to deploy a threat hunting program in your environment. As Carl mentioned, as well as we're going to go through, please put any questions that you have in the chat window. We'll address those at the end in a specific Q&A section. Now, generally, the benefits, before we dive into today's content, the benefits of threat hunting is really revealing missing data sources which you may thought you might have had, or data sources you may need because of different threats having different capabilities. Beyond that, this is not something in ICS that's going to be done in isolation, which is a good thing. You're going to expand your knowledge of the engineering aspects in ICS and OT, but it's also an opportunity when threat hunting to engage with engineering staff, operators, and whatnot as well. And this allows those discussions on the plant floor for ICS-specific threat landscape discussions, which is all about the educational and awareness, which goes both ways, again, prioritizing safety. Beyond that, of course, threat hunting does not just only focus on scoping IOCs, which can change rapidly. We'll show you that in a moment. It's really about getting ahead of the adversary, but it also can uncover misconfigurations from an engineering or networking perspective as well. So yes, threat hunting is not just beneficial from a security perspective. And of course, again, I'm saying it so many times because it's so important, leveraging cyber threat intelligence for a proactive defense in an environment. In case we all forgot, threat hunting is really a proactive process, but the objective here with this slide is just to remind us that technology alone is not going to save the day. Using technology to streamline some of this and automate some of it is going to help, but in general, we're really looking for human defenders using threat intelligence to drive hunts. And we'll talk about hypotheses, we'll generate a few, and in the next session, we'll actually execute those. So all about the incident before it actually happens. So in part 2, we're going to discover the critical cyber assets that is applicable to all ICS sectors pretty much. We'll talk about the related data sources around those top 4 critical ICS assets. We'll use an example of threat intelligence for ICS, look through control network traffic, and talk about security event retention as well. So when you go do your hunt, what should you expect from engineering devices, OT, Windows boxes, and so on, and from the network as well. Beyond that, at the end of this session, we will give you that threat hunt package template, which generally lays out a table of here's your objective, here's the scope, kind of helps you document what the purpose is of your threat hunt and what you're going to do and how to execute it. So let's jump right in. Now, these critical assets we've covered many times before in many different sessions, but I do want to raise them again here and really pivot from these four and really talk about the related data sources in and around these assets to do threat hunting. Now, of course, as some of you may know, they are as follows. I'm going to start with the data historian, which is usually the asset or a couple assets that are more closely towards the IT network, but definitely should be on the ICS network, usually in a DMZ. And we'll talk in a moment about where these assets fit aligned to Purdue. The data historian, of course, is generally a database that stores operational process records. So if your electric power industry, for example, it's going to store things like the load on the system, the demand of electricity in a region, and so on and so forth. Similarly, if the data historian in a pharmaceutical environment, it's going to have records such as the types of medication being constructed, produced, and the recipe essentially of that medication, vaccine, or some kind of other medical product as well in the data historian. Now, beyond the data historian, we're going to pivot to the human machine interface, of course, the HMI, because it's super critical. This is the on-screen interface between physical process. Operators are going to be using this physical process or the on-screen connection to the physical process to monitor, control, and change industrial control system applications, essentially, and the process itself, the changing real-world things in the real world. Now, we do know that these assets are generally targeted by the threat intelligence we have seen in the past several years. So this comes as no surprise that the next asset on the list, where we want to start hunting, is an engineering workstation. So the engineering workstation really hosts or has the installed engineering software they use to program and change the programmable logic controller system logic, firmware of devices, configuration of devices in the field, and so on and so forth. So all of these together will make up the critical assets we're going to start doing our hunting around. And last in this list, but certainly not least, is very low in the Purdue model, or very low in the control network. It's the PLC, of course, a programmable logic controller, which actually runs the plant floor, the code that is programmed with it using the engineering workstation. This, of course, will be the actual commands executed to change the process. For example, if you're a cookie factory and you wanted to add additional chocolate chips to your cookies, then you could do that using the engineering workstation logic, and of course, program that into the PLC, thus more cookies and more chocolate chips, everybody's happy. So all of these assets, there's no secret behind these. These are the assets that are generally we see being targeted, not the only assets, but if we start hunting around these assets, we're really doing a lot of good defense work, kind of getting ahead of the adversary wherever we can. So the next question usually is, where do these assets lie in the Purdue model? And so just to kind of show you this, we're going to take a look at some images and align each of the image with that critical asset. The data historian talks about and stores the process data, of course, graphing trend information is at the top. Now, the human machine interface, here is an example here on screen of a human machine interface that operates the generation, transmission, and distribution of power to a region from an industrial perspective, but also to residential customers. And the engineering workstation you see here, this is the code that's created and written to push onto the programmable logic controllers. And here you see a rack of PLCs and input-output cards, which run that code, sense the environment through the input and output, and make changes through the output cards in this PLC chassis. So these are the primary devices we're talking about. And generally, when we're looking at the network, you're typically going to find them aligned to Purdue like this. Not always, but if you're following the Purdue model for best practice architecture, you're typically going to find a data historian, likely in the DMZ, such as other applications that could be housed inside the DMZ as well, such as jump hosts, etc. But the data historian is going to be typically in the upper level of the Purdue, but still associated with the OT specific network, although it may have a connection to the IT network where IT may have access to get data, pull data from the historian, or maybe it's pushed from the DMZ into IT as the best practice. Of course, moving down a little further into the supervisory control elements, we have the human machine interface here, but it's also the area where you're typically going to find the engineering workstation devices, which again, thinking now from a perspective of threat hunting or specifically attacking a control system, looking at the upper level of the Purdue coming down, there's a pathway there that an adversary can take from historian to HMI to manipulate the process and so on and so forth. If the adversary is in the engineering workstation, of course, as you guessed, has the capability to change things at the lower level of the Purdue as well, directly the PLCs, which are typically in the control elements level in the Purdue model. And of course, we have the sensors and actuators below that make the actual physical change in the real world. So this is where you typically would find them, anything between Purdue level 1, for example, all the way up to level 3 or 3.5. And of course, the level 4 and 5 at the very top of the screen could be the business network, or potentially a plant-wide network in a specific SCADA environment. So those are the assets and where to find them. Now, the most important thing in our context, talking about threat hunting, is really how do we hunt and look for data that could be there indicating a potential threat in the environment. Well, we're going to talk about the related data sources to those top 4 and a few other devices as well. And we're going to start with a device low in the environment, an engineering device. We're going to take the example of the PLC, but the PLC could also be a remote terminal unit, and the same kind of aspects apply when we're talking about the data sources. Now, on screen here, we do have a PLC chassis like we've seen before, and this device will have critical information about what's happening on the plant floor. Now, we'll get into exactly the types of security events or logging events we want to get into when we do threat hunting in number 3, episode 3 of this series, when we really dive into executing an actual threat hunt. But for now, we're going to really focus on making sure we have data available to us to actually execute the hunt. Forensics analysis is awesome and it's super cool, but it's not magic. So if we don't have data, hunting is going to be limited to some degree. The other side of that is that when you do hunting and find you need data and you don't have the data, that's a plus as well. You have action there to kind of get more defense. But looking at the engineering device, a PLC, RTU, et cetera, we're talking about engineering systems in the field. Now, the data you're looking for when you're doing threat hunting can be on those devices specifically, which means locally stored on those devices. That may mean you have to go to a site physically to access those logs you're looking for. And this, of course, is where engineers at site can pull some of those logs for you as well to help in your threat hunt initiative. And again, a reminder is threat hunting doesn't typically happen in ICS in a contained kind of isolated environment. It's like a party, right? There's like a lot of folks involved, and doing it delicately and really for the purpose of engineering and safety and reliability of operations. So the other option as well is that some of these devices remotely now in the field, in today's kind of technological world, we do have the ability to do remote access into the devices, but more specifically, again, we're hunting, looking for data. We can get logs from the devices coming into a syslog capability you may have, or a SIEM on the ICS network as an example. Either way, critical to have your logs enabled at this level in the control environment, and not just things like the human-machine interface running on a traditional Windows system, which is still an OT device. So going lower in the Purdue model is also helpful for sure, going beyond just traditional assets. Now, of course, with the traditional assets, which are OT endpoints, they can be your traditional Windows OT or Linux OT device. And of course, we talked about the HMI and the engineering workstation. Typically, these are on those traditional operating systems, still treated as an OT environment. Now, our purpose here to focus on threat hunting is really zero in on the data from both the operating system this engineering software is running on, but also the engineering application logs as well. So you're thinking, can you give an example? Okay, great. So if there's an access control list as an example on the application, that may not necessarily be stored in the application or security event logs on a Windows or Linux device. Therefore, we have to go beyond that and look for the engineering software specific application logs to understand if that software may have been logged into, changed, or being abused. So the Windows and Linux host operating system logs in addition to the engineering application logs as well. Now, beyond that, of course, another possible OT device could be your data historian, which can still be running on a Windows device, patched and whatnot, and treated as an OT device. But the historian also has the traditional application logs you're going to look for, the operation or operating system logs as well. But beyond that, it has critical information such as that process data, the engineering data, the trending and analysis information on the process in your critical infrastructure. Now, what's interesting about just looking at the trending data from a defense perspective is you can quickly understand what is happening in the process. So if you see a valley or spike in the data from the data historian, it could indicate a change, which of course may or may not be security related, but we do see it as a valuable resource to do threat hunting to understand what changed in the engineering side, which may or may not be applicable from a cyber perspective. But again, we cannot overlook that trending data. Sometimes it may be the only data available and you don't have things like your operating system logs, application logs. So again, trending data is super important there. As we talked about before, the application log, so logging in and access control. And you see an example on screen here as well. This is a Windows example where we see an account being locked out. That can trigger some interesting kind of spin-off conversations. And so maybe that's a hypothesis we'll get to in a little bit. So suffice it to say, in addition to the data historian logs, on-screen HMI application logs as well. So let me back up for a second. When we're talking about traditional OT assets and the HMI, it's the operating system logs. It's also the application login, for example, access control, but also the HMI when it makes changes or when an operator clicks on something and has a command executed, that can also be logged and audited. And that's also critical because as we're doing threat hunting, we also are aware, because we're ingesting threat intelligence for ICS, that the adversary doesn't always have to use malware. If they get access to the HMI and click an icon that releases or de-energizes an environment, for example, in an energy sector, then that does have impact. So logging those commands and execution of those commands from the HMI's perspective is also critical. Now you're probably thinking, okay, great, we've talked about the endpoints, we've talked a little bit about those assets. What about the communications to and from those critical ICS assets? But what are we looking for generally on the network when we do threat hunting? So there's 6 top things we're going to focus on when we're talking about threat hunting in ICS environments, specifically around the control network data. So think high level Purdue, but going right down deep into the Purdue as well to get the control traffic. And here they are. Generally, when we're hunting, we definitely want to take advantage of at least the 5-tuple or IP fix or net flow data to and from the human machine interface and the controllers in the network as well. So the PLCs and whatnot, to understand what commands are going to the endpoints in the field from the human machine interface, but also the operators, of course, as well. Now, if we do have full packet captures, that's the ideal state from at least level 1 to level 3. That's again the ideal state, full packet analysis. That may be asking a lot depending on the infrastructure that you have, because it does require a lot of space for that, generally less than IT though. But we're looking at number 2 now. We're looking at engineering workstations to the controllers as well, critical for threat hunting. And this communication on the network will allow you to understand what engineering workstations that are, I guess, essentially allowed to, purposely authorized to communicate to the PLCs. And if you do see that communication outside of what you expect, outside of an engineering approved change window, then potential malicious activity could be at foot. Beyond that, of course, as in general, looking for the north-south traffic, so internet bound, inbound and outbound network connections are also going to be critical to pick up things like C2s and exfiltration attempts, et cetera. Login access as well, remote access to a jump host in and out of level 3.5 potentially, or level 3, wherever your DMZ is for the ICS, is also critical to capture that data wherever you can, north-south in this case. And of course, in number 5, we're talking about, again, the north-south, but also the east-west traffic. So not only is there an HMI going to the internet, we also want to understand, from the PLC level or engineering workstation level, are those devices communicating back and forth laterally through the network as well? And again, just a reminder, if we only get the IP fix data, so the IP source destination, for example, protocol and port, that's definitely helpful, but wherever we can for hunting, it'd be excellent to have a full packet capture. And I'll show you in a minute why that's the case. Now, still speaking about the network here, here's an example of why it's important to have full packet captures, not just the 5-tuple or IP fix data. Again, we're looking at the control traffic specifically. So getting things like the actual Modbus TCP, Profinet, DMP3, 104, ICCP, S7, and so on. All of that traffic is very important at the packet payload level to understand what communications and specifically the commands are being pushed onto the network to be executed by devices in the field and to and from the traffic to and from the HMI. So what you see on screen here is just a packet dump from Wireshark. It's a PCAP from a plant network. Now it actually shows us the types of traffic that's in there specifically to the industrial control. So we do see Modbus TCP and so on and so forth. And again, this is an example of at this point now with just a simple tool like Wireshark, you could do hunting specifically going beyond just the IOCs, which could be just a port number and an IP address. Now we can look at the types of commands on the network, which may be related to a command abuse or some living off the land, which we have seen in our sector several times now in the last couple of years. So just an example of this from the network perspective, and another reminder to drop any questions that you have in the chat window. On the screen, we do see network activity. This here is at the packet level, so we do have full packet capture. And then we do have evidence of a C2 command and control activity from the internal control network to the outbound internet, possibly for, in this case here, exfiltration, but we also see activity going directly to the HMI. Now, this is going to be interesting, and we'll come back to this when we start building hypotheses, because this is not something that's new. So gravitating towards the HMI, doing exfiltration, even pings, for example, as you see on screen with very low bit count, transmission count, et cetera, of packets and data can be beaconing to establish that C2. So here we do see a potential access towards a HMI on 3389, which could be the RDP access, which can be legitimate from certain sources, right? But in this case here, it's not legitimate whatsoever. If we take a look at now from a threat intelligence perspective, how did we come upon that IP address we just talked about? Where did we get that information? How do we start scoping? Of course, this goes right back to yet our last conversation in this series about threat hunting and threat intelligence and leveraging it for specifically from the ICS areas. Now, I'll just touch on this slide briefly. We did talk about it last time, but here again is the no-cost ICS cyber threat intelligence sources, which is a great place to start your ICS hunting, at least getting data about the adversary in the environments that you have in your sector, for example, sector specific being the best, of course. So starting here is a great place to start, and again, at no cost or low cost. But when, of course, you do decide on threat intelligence and you start ingesting threat intelligence to scope your environment generally or start your threat hunting, you're going to be really focusing on a couple different things. You'll focus on the operational side of things, which is the operational indicators of compromise. So we'll talk about that in a second and give you a run through of an example. And also the tactical TTPs, tactics, techniques, and procedures. Again, thinking ICS specific wherever we can. If we take a look at the IOCs and really pull out the differences between IOCs and TTPs, we're coming down to IOCs being something like a signature, an artifact, IP address, file name, file hash, and we've all seen these before. And an example goes right back to a couple slides ago where we've seen that 5 dot address, which was on the internet connecting to our HMI over port 3389, which is RDP, which could be legitimate, and our case was not. This can be accessible through threat intelligence, which you ingest, get that 5 dot IP address, and then scope at least your 5 tuple data. If not your 5 tuple, then go into lower level of the packet payload to understand if it's malicious in your environment. Now, as we're going through this example, we have a maliciously defined IP address, which is a C2 associated with malware, can be used for exfiltration of data and also remote access into your communication network. We can also see that this actually creates for us, from a threat hunting perspective, a possible hypothesis. So hypothesis, and this is an easy one, we'll get to cooler ones in a second. The hypothesis is, well, we have an IP address, we've ingested threat intel. Are we impacted by this? Do we have an adversary using this IP in our network? And you're probably thinking, maybe that IP is only one of many IP addresses the adversary uses. So maybe this hypothesis is not as cool or as strong as one we'll show you in a minute. And you're correct on that. But it is generally a hypothesis and a great place to start threat hunting initiatives. So in this case here, we do have a threat hunt hypothesis. Specifically, we're going through a PCAP, we're looking for a specific IP address. We do see that IP address in the network. So in our case here, threat hunting does return something from our actual efforts, indicating we do have connectivity to a number of different devices. Now, here we are looking at just the 5 tuple. Of course, we do have the full payloads as well, because this is in Wireshark. But if you only look at the 5 tuple, you can discover this type of information as well. Now you're probably thinking, okay, well, IOCs in general, how important are they versus TTPs? I love that you're asking that question. I know someone out there is asking it, and there's a huge difference there. If we look at IOC specifically, yes, they are volatile. They're easy for adversaries to change when they actually change their attack infrastructure. So they really have IOCs, specifically when it's an IP address, have a limited defense use. It's more for reactive focus. We know this is related to a signature that's compromised, utilities in my sector. Are we already compromised? Like, that's the whole objective. Scope to see where the infection is already versus how do we get ahead of this to make sure an adversary cannot execute this in our environment. So an IP address, I'll pick on that one as I always do because it changes so quickly, and all of us are inundated with IP address lists day in and day out. So there is a limited kind of use for those, and the IP addresses decay their value over time very quickly. And we take a look at it from a TTP perspective. This is more focusing on the behavior of an asset. And yes, we have another hypothesis coming in a moment. This is really focused on the tradecraft, how the adversary generally has been seen taking advantage of, breaking into, exfiltrating, and causing impacts inside control environments. Now, specifically here, as an example, right, that we have seen several times, is that an adversary focused on the ICS network compromises an IT system, pivots potentially from the IT network through a data historian, the trusted assets, which we all know and love, and potentially as well, an example would be having that connection, RDPing to the HMI, just like what we seen earlier in the PCAP, but not having the context, only using the IP address, and then using something like Mimikatz to make that pivot happen. So if there is, for example, a shared AD or Active Directory infrastructure on IT and on the ICS network, if those credentials are available on IT, the adversary could use those using standard tools like Mimikatz to harvest them and try to pivot digitally into the ICS. And yes, we have seen this before. And boom, there is our other hypothesis. This is a stronger hypothesis because it is behavioral, because the IP address example was really 1-to-1. One adversary group using one IP address, which changes very rapidly, and that's reactive. However, here, there's way more bang for your buck. We do see an adversary use this kind of capability time and time again. So when you understand this risk surface in your environment and you work to reduce that risk or mitigate that opportunity for the adversary, it's not 1-to-1 anymore, it's 1-to-n. Now you're stopping on a larger scale, one-to-many adversaries using the similar technique as well. And these TTPs, what you see on screen, this hypothesis, is harder for the adversary to come up with when they're looking at taking advantage of the ICS environment. So a great hypothesis, which we may use in our next session when we actually do some actual execution of threat hunting. So we did talk about the data sources as an example, and that it's super awesome to do ICS incident response and, of course, forensics analysis in any environment, but again, it's not magic. So we have to understand where the data is and also understand the retention of the data in the engineering assets, in the different fields, in the physical industrial control system sites, and so on and so forth. So I'm going to walk you through a very quick table, and this table can be used for you to map out what you see in your environment around these critical assets. So again, if the data is not there, or if you come there and the data is 2 days old and the adversary was in there 7 days ago, you're not going to get what you're looking for from a threat perspective. So understanding this before you do a threat hunt is really going to give you more value. So specifically, of course, the HMI, let's pick on that one because why not? And it's awesome. So the HMI could be a Windows-based device. In this case here, the data type could be a Windows host, HMI application logs, and the data storage location could be in a specific IT or OT or ICS SIEM, for example, maybe or not, could it be converged? And the data retention here, which is really good, 120 days potentially. Not always the case. Well, I've done assessments and we've done assessments where that's not always the case. But in this case here, we're looking pretty good. We're going to get a lot of value probably from our threat hunts because we have data to sift through to understand where the risks and threats are. Now, beyond that, of course, now we're going right down in the field. These devices, the PLCs, could be remote. They could be in remote physical locations, but the logs on those devices that have information about the firmware device being updated or not, logic changes in the device, and so on, critical information from a threat detection perspective in ICS. Here we do have a data retention of 60 days, and it is local to that PLC in this case. Yes, PLCs do have tend to have more so now than before web access interfaces. You can actually do a web HTTPS into a PLC to get its status information and also get the data logs, right? The security logs. So it may have that capability, it may not have that capability. And remember, when you're doing your threat hunting, executing it from a physical location may limit you to the data you're going to get. This again may require you to get to a specific site, which is awesome. I totally recommend getting the site for threat hunts for the other benefits we talked about before. Now, another example here, going beyond a control network in a electric facility and electric generation facility. Now we're moving on to the transmission substation, where you have different devices inside the ICS. Yes, of course, PLCs, but you may have in this case protection and control relays, which may be a proprietary log type, so not a standard syslog type or something of that nature. You may have to use engineering software to get access to those proprietary logs and exfiltrate them off the environment, or at least read them to understand what's happening in the environment from a threat perspective. So as you're developing your threat hunt capabilities and your hypothesis, keep these things in mind. Again, here we do see it's contained local to the device with no capability to retrieve logs remotely. So you have to get to site for these kinds of logs in some cases. Notice as well, we do see data retention of 30 days rather than the higher 60 or 120. So drastically can change your window of time for threat hunting as you kind of pivot through. And similarly, of course, I cannot talk about threat hunting without looking at the network. So if you have a network appliance, which literally could be a laptop with a terabyte hard drive hooked up to it running Snort or Security Onion, if you have that capability, then awesome. Doing point in time PCAPs are way better than just doing your IP fix. So wherever you can get that full PCAP, as we talked about. But here as well, you can be taking a lot of data and storing a lot of data, which means your data retention could be lower. So consider that when you're looking for the network. And yes, the network data is critical for threat hunting. Here we have 7 days, and it could be local to the device, but it could have standard full packet capture. So a lot of value from this kind of data. So now you're thinking, great, we have a little bit of information about the critical assets. We know how to get some of the data that's there. We know that it could be remote data, it could be local data on the devices as well. And how do we organize this to put it into what's generally called an ICS threat hunt template or a threat hunt package? Organizing your threat hunt, and really we can do this with the next table. Now the next table is really got a lot of text, so I'm going to bombard you here in a second. But don't worry, in the next session, we're going to go through each one of these and build it out ourselves together. Now here with this threat hunt package template, you're really going to be talking about the threat hunt element and the description. And of course, it's going to start off with your purpose. In section 1 of this series, we talked about why would you threat hunt? We talked about metrics of threat hunting. And so just a reminder, your objective may not be best saying, well, how many adversaries did we see this week or this month, right? Really, the better return of investment is how many things can you change proactively tied to a threat you've seen in your sector to reduce the habitable nature of your environment. That's a metric you can follow to give you good results every time. Or looking at the data sources you expected to be there and finding that they're not there, how many of those did you fix along the way? Or how many things from an engineering perspective, misconfigurations, were you able to help with from a security perspective to help the engineering out? So again, the purpose is, finding things like gaps in data stores, or finding things like adversary scoping TTPs or scoping IOCs, for example. That could generally be your purpose. A hypothesis we've touched on a little bit there, one which is a weaker one, and the stronger one focused on TTPs, which is where I'd suggest you follow because it's more return of investment. The data sources, again, you may not know all the data sources as you pivot through your threat hunts. So start with the data sources we talked about before and the critical assets, which we talked about, those 4 main ones. Beyond that, of course, depending on the data sources you have the ability to do a sweep for IOCs, which does have some value. But again, you can do more strategic TTP analysis as well. And your actions could be do a hunt, find something to improve, and then take that improvement or lesson learned and follow that through the engineering change process to actually make a change in the field, as an example. Now, the last but not least part of the threat hunt package template is the sites and teams you're going to be interacting with. Obviously, going to your sites, which are the most important for your business, the most important for safety, is a great place to start. But of course, having the teams there to help you pull the logs from the field, as an example, or get the PCAPs from the switch at the lower level of Purdue is critical. So I highly recommend obviously coordinating this before you get to a site. And most times you have to anyway, getting to the site, you have to have physical security or physical safety training completed. So I would definitely recommend planning this out using this template, and the teams you'd want to have included in your hunt, of course, are things like the folks like the operators. Yeah, potentially the IT security team as well, the physical security team or emergency management team. Great opportunity again to get everybody together to see where the data is, where the devices are, but also how you can get and pull that data to make your hunt successful. Now, we will fill out a complete version of this as we generate hypotheses in the next session. And as we get closer to the end of this session, I do want to go over a couple of quick takeaways to kind of understand those assets, build up your package, and understand what data sources could be available to you when you do create your threat hunt package. So namely, these are the things to take away from this specific session before we jump into some Q&A. So looking at the takeaways from part 2 here, ICS threat hunting takeaways, consuming ICS specific threat intelligence is obviously going to be the best solution for you. Now, what I mean by that is really intelligence that's tailored to ICS, hopefully your sector specifically. As an example, if you're in electric, the EISAC, as an example, is specific to that sector. But really, we're focusing on the threat intel that has information about engineering assets, the engineering aspects of how the adversary has been moving. So another resource could be leveraging the ICS MITRE ATT&CK, for example, as well. The data sources we talked about, hunting around those 4 critical, these are all applicable to many or all of the ICS sectors that are out there. So if you're just starting your ICS threat hunt, then start around those 4 to get a lot of value. Beyond that, of course, leveraging those 2 tables we talked about, data retention, but also the threat hunt package, which we'll execute together in the next one, is a critical, easy way to kind of put everything together to prepare you and your team before you do execution. So where are we in this series? We talked about number 1, which is where to start and the benefits. And today we mostly focused on things like data sources, building out a hunt package template. We talked a little bit about 2 of the hypotheses, one being weaker than the other. And of course, the value of focusing on TTPs, and of course, the value of focusing on full packet captures wherever you can at your major sites that you want to protect first. Now, the next session, we are going to talk about that threat hunt package and actually execute that. So in the next session, we will have those threat hunts and walk through each of those stages, jump to different assets and understand what specific things we're looking for. Event IDs, as an example, communications on the network, and so on and so forth. Try to piece together a threat hunt and an actual activity, an event inside the ICS environment. Before we get to the Q&A, which is coming up in just one quick moment, I do want to remind you that the ICS Summit is coming up in June, and you are welcome to join us. You can actually join us for free online, but you can also join us in person as well in Orlando. And the summit is actually the 2nd and the 3rd. The training that follows is the 4th to the 9th, but we do have a SANS and Dragos Capture the Flag Day on June 1st. So lots of cool stuff happening in the upcoming months. So please take a look there. And without further ado, let's jump into the Q&A for this section, which is threat hunting part 2. And for this, I'm going to turn this over to Carol to help us out with the questions.
All right. Yes, thank you for that great presentation. We have some questions ready for the Q&A. However, if anyone has a question for Dean, please enter it into the questions window now. Our first one asks, will network or endpoint threat hunting disrupt the control systems when actually hunting?
Yeah, it's a great question. So if done correctly, no, it won't cause any disruption. Generally, what you're doing with threat hunting is you're just retrieving data. Of course, you're doing that within the means of your engineering workstation, your HMI, and the windows of opportunity from the engineering staff that are available to you. So great question. And this is why it's important to coordinate your threat hunt when you get to site. So as an example, if you need logs from the HMI and there's some kind of maintenance happening and the HMI is being tested, not a great time to pull that. So you could disrupt things that way, but generally not going to be disrupting the environment. Another good example of threat hunting that's passive is looking at the network. We focus a lot in this session on the network and pulling network data from a passive environment or a passive switch, for example, or a tap that's already set up is very little impact or no impact on the industrial control environment. So generally, you shouldn't have any issues with conventional threat hunting in ICS. Great question.
All right, thanks. This next one says, can you suggest other assets to start hunting around inside ICS other than the ones you've mentioned so far?
So it definitely would depend on the infrastructure, the sector as well. What immediately comes to mind from my experience in oil and gas is in refineries or even offshore tankers come up to refineries, for example, to download, offload and unload crude oil. Typically there's a marine terminal, and that marine terminal is not your refinery. It's not your always your storage facility. So those sites may have additional assets. They'll still have things like controllers to physically pump the crude oil off. So I would consider things like the mono buoys that are floating infrastructure that allows tankers to connect to them and download or offload that crude oil. I would consider those assets to be considered in the threat hunt realm. In the electric sector, for example, we kind of touched on it earlier, but protection and control relays, meters, for example, in the electric sector, or other assets you want to take to understand if there's any threats around as well. So communications to and from those assets beyond the four we talked about is critical. I'm going back again to the network aspect there for sure. Great question, though.
All right, thanks. Let's see. I've been tasked with building an OT security team. Should we start hunting first when the team is built? What should we do first?
Yeah, so we kind of covered it on the first session, but it's a great question that we get a lot, which is awesome. So it depends on where your team is and what infrastructure you have in place. And I guess, we've talked a lot about having the data sources available to you. So I would suggest that if you're building the team and you have at least network visibility, you can definitely start right now doing threat hunting if you have the resources available to you. However, if you don't have things like architecture in place, alignment with Purdue, things of that nature, I would probably focus the energy there first, get architecture in place, passive defenses, and then really look to what you may have in place for a network visibility or deploy network visibility. I would go in those stages. So great question. It depends on kind of where you are, but those are the progressional steps we see to get the most value out of ICS defense for sure.
All right, thanks. This next one asks, what's the difference between cyber threat hunting and network intrusion detection?
Great. Yeah. So that's a great question. And I love how it's intrusion detection system. In ICS, I do want to point out, generally, we don't see a lot of intrusion prevention systems, but the difference between threat hunting and threat detection is really more of the passive versus reactive, or passive versus proactive, where threat hunting is, how can I think like an adversary? What have we seen the adversary doing? And can we find traces of that? Not necessarily an IP or hash or a file, but how can we see that it's possible for an adversary to get into the ICS and then pivot to actually cause an impact? So in general, I would say threat detection, IDS, is probably mostly looking at signature based on the network. That's my assumption in this case. Whereas threat hunting is looking at not only IOCs and signatures, it's really going beyond that to look at tradecraft in the network. So I would say that they're definitely different. And I would say that threat hunting is more of a mature look at a network. And of course, the requirements are having people beyond technology, whereas IDS is just technology. So hunting is having the people and the data sources you need. Great question.
All right, that's all the questions I'm seeing. Do you have any closing thoughts you'd like to share?
No, I think that's great. Thanks everybody again for joining for this session for number 2, and looking forward to the next session, which will close off this series on threat hunting for the ICS when we walk through a threat hunt in the ICS environment. So thanks for having me today again, Carol, and thanks everybody for joining.
All right, well, thank you so much, Dean, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.